What do you get when you cross 5 intelligent engineers with one big problem? If you guessed a semester filled with ups, downs, a huge pivot, conservative estimates, and annoying other teams by turning the Red Room into a hot sauna, you're spot on. Hi, I'm Stephanie Vo, the Agile Product Design team lead this semester. ABD is a little bit different than the other teams you've seen tonight, in that we start our semester off a little bit earlier in the commercialization process. We began with an open-ended clean sheet project, and we're tasked to solve the problem of reducing food waste with a tangible product. So this team of engineers has investigated 5 spheres along the food waste cycle and identified a multitude of pain points anywhere along in a multitude of countries all over the globe to identify key pain points, and they have ideated over 80 ideas to come up with one solution, the FREO. This solution has the potential to reduce food waste in developing countries and impact these countries environmentally, economically, and socially. It's been quite the journey this semester, leading these 5 delightful, intelligent, hilarious team individuals, and I cannot say how proud I am of them, of taking an idea and catapulting it into reality. So, without further ado, please let me introduce you to Team FREO, Matt, Joe, Courtney, Mario, and Stephanie.
Beatrice is a food vendor in Uganda's capital city of Kampala. Day in and day out, she works in their hot, open-air markets. And while she is able to stay in the shade, her produce isn't as lucky. Due to a lack of reliable access to electricity, a lot of the common options, such as refrigeration and ice packs, aren't available to her. This leads to a large portion of the food that she's trying to sell spoiling before she gets the chance to ever get it into the hands of a user. Now, picture hundreds of thousands of users, just like Beatrice, all across Uganda. With these vendors in mind, the Agile Product Design team has developed our product, FREO, an electricity-free cooling system. With the interviews of more than 20 vendors in Kampala, we have tailor-fitted our product to fit these users' needs. We believe that with a licensing program and working with local manufacturers, we will be able to provide an efficient and inexpensive product for these users. Hello, my name is Matt Allen. I'm a junior mechanical engineering, and I'm from Downingtown, Pennsylvania.
Hi, my name is Joe Chirunji. I'm a senior industrial engineering from Kampala, Uganda.
Hi, my name is Courtney Duckett, and I'm a sophomore industrial and systems engineering from Oklahoma City.
Hello, my name is Mario Perez. I'm a mechanical engineering senior from Zacatecas, Mexico.
Hello, my name is Stephanie Prado, and I'm a sophomore in mechanical engineering from Maracaibo, Venezuela.
Our team leader is Stephanie Vo, and our mentors are Stephanie Owens and Alyssa Patel. Vendors like Beatrice don't have a whole lot of options. They work in this hot, crowded, and sometimes unsanitary space. Additionally, these vendors only make about $25 a week, which means that every little bit of food waste directly impacts their bottom line and their way of life. And there is quite a bit of food waste. We have found through interviews that sometimes up to 20% of the food that they are intending to sell spoils in the stands. In addition to that, whether the food spoils or is sold, these vendors need to replenish their stock, which leads them to hiring out these men who will both get the food from the distributor and carry it safely back to them. This means that they're spending money on food, which is partially spoiling, spending more money on getting more food, which will then partially spoil. We saw this as a vicious cycle and wanted to make an impact on it. We believe that these vendors needed an option that would be an effective and inexpensive solution to their problems that would reduce the amount of food that they are wasting, as well as reduce the number of times they need to make this trip to the distributor. To show how our product FREO will address these issues, here's Joe.
Thanks, Matt. So now that Matt has told you about the current situation that most market vendors in Kampala find themselves in, I'm going to talk about the features of FREO and its functioning. One of the biggest contributing factors to this technology gap is the lack of electricity. With less than 20% of the Ugandan population having access to reliable electricity, electric-powered storage products are not really an option for most of these vendors. FREO directly addresses this need, using a process called evaporative cooling. Evaporative cooling is a naturally occurring process that takes place when water comes into contact with warm air. This happens in several everyday instances. When you're sweating on a hot day, for example, and stand in front of a fan or in a breeze, Latent heat is carried away from your body through the sweat evaporating at the surface of your skin, leaving you feeling much cooler than before. In the case of FREO, water that is poured into a thermal mass allows warm ambient air passing through that thermal mass to become cooled through evaporation of water at its surface, which results in a temperature reduction and an overall cooling effect. Using this electricity-free process, FREO provides an affordable alternative to refrigeration. To use a conservative example, the average cost of a compact refrigerator is about $150, while the unit cost of FREO is set at $20. This makes it 83% cheaper than some of the cheapest solutions currently available. Not only is FREO affordable, it's also effective. Able to achieve a 27-degree Fahrenheit temperature reduction, FREO can bring market conditions as high as 82 degrees Fahrenheit down to a low of 55. This increases the preservation length from an average of 2 to 3 days to an average of 6 to 8 days, more than doubling the shelf life of fresh food. FREO is also designed using cheap materials that are all readily available. Some of the material cost considerations that went into the design of FREO include using wood for the frame, aluminum for the storage chamber, a loofah and soil mixture for the thermal mass, a simple plastic transparent lid for display purposes, and finally, ferrous cement for the walls. All of these materials were carefully chosen through extensive research in order to optimize both the cost and effectiveness of FREO. For example, an elliptical shape was chosen for the storage chamber in order to maximize both the carrying capacity of FREO as well as the surface area from which evaporation takes place, as well as minimize the cost of the material. For the aluminum is also easy to clean and does not rust, so it provides a clean and hygienic storage chamber for market vendors like Beatrice. For the walls, we chose ferrous cement because it allowed for a degree of permeability or porosity, where it would allow water to evaporate through the walls of the product without allowing it to leak out of it. It's also a lightweight option to allow for a portable product, so these vendors can move their produce around. And finally, two important considerations were taken into account for the thermal mass: the water holding capacity and the maximum capillary height. If the thermal mass became waterlogged or allowed water to accumulate at its bottom, it wouldn't allow for even evaporation to take place throughout it. So these two factors were important, and given that the loofah soil mixture met both these functional requirements, it was chosen as the ideal thermal mass. So having talked about the features of FREO, its functionality, and why we chose the materials we did, I'm going to pass it off to Courtney to talk more about our prototyping process that led to this final design, and also how FREO is competitive on the current market.
Thanks, Joe. We designed the FREO with our users in mind.
I felt like I was rushing through it.
We designed our FREO with our users in mind. Through a series of interviews, we found that our users thought that the price of the FREO was the most important part. With that being said, they needed a low, inexpensive solution to storing their food. That posed a huge challenge to our team. So for our prototyping, we not only had to create an effective evaporative cooling device, but it also needed to be made of materials that were inexpensive and easy to acquire in Uganda. We began our rapid prototyping in the CCEW office in a small room with a heater turned all the way up to simulate the warm temperatures of a Kampala outdoor food market. We began with prototype 1.0, which was made out of terracotta pots and sand as our thermal mass. We found that this didn't get very cold, so instead for prototype 2.0, we used lighter materials such as aluminum and sponge for the thermal mass. To get it to be even colder, we found that we needed to make the outer walls more porous. So for prototype 2.1, we cut holes in the outer wall and lined it with a thin wire mesh. While this did make the internal temperature get a lot colder, the materials and cost of manufacturing were far too expensive to be feasible in Uganda. However, through this rapid prototyping phase, we used the insights from our tests to determine our final and current design for the FREO. Also, by talking to our potential users, we were able to get a better understanding of how they sell food at the market on a day-to-day basis. We understand that they sell large amounts of food at a time, and they prefer to have their food on display for their customers to see. With that being said, we understand that food storage is key to food preservation, so we sought to find the current options that our users have and determine where the FREO fits. The FREO is a device that reduces the temperature of the food that it stores while allowing for the food to be on display. It is affordable for our potential users and has its capacity is large enough, which is ideal for these market vendors who do sell large amounts of food at a time. Alternatively, what they're currently doing is using things like boxes, crates, bins, and bags to store their food. This method does not reduce the temperature of the food that it stores. And while this method might be expensive to acquire the materials, it leads to a loss in profit because food isn't being preserved this way. Similar to the FREO, there are other evaporative cooling options out there, such as the Evaptainer, the Mid-A-Cool fridge, Cummins Pot and Pot, and the Zerpot, of which all of these do reduce the temperature of the food that they store. However, none of them were created with market vendors in mind, like the FREO was. And finally, as Joe mentioned before, there is the option of utilizing a compact refrigerator or a mini fridge. And while this would certainly reduce the temperature of the food that it holds, the unreliable electricity in the marketplace makes this an unfeasible option. And now that you understand how we came to our design through prototyping and our user needs, I'll have Mario tell you a little bit more about our market in Uganda.
Thank you. FREO's initial market of Kampala, Uganda consists of thousands of vendors just like Beatrice. So as mentioned earlier, Beatrice faces many issues being a fresh food vendor in Uganda that contribute to food being wasted. However, it's important to note this is not an isolated issue. With over 5 million fresh food vendors, when analyzing countries in Africa with climates adequate for FREO, it is clear this is a widespread issue being faced by many individuals. The FREO team will target Uganda, which has 750,000 fresh food vendors currently. This creates a potential market of potential conservative market of 18 million. To be more specific, we will target the capital city of Uganda, Kampala. There are many characteristics that went into choosing Kampala as our first initial market. The first characteristic is the lack of major competition. As mentioned by Courtney, there are devices that use evaporative cooling currently. However, none of them are being sold in Kampala or currently being used in Kampala. Secondly, there's an established user interest. During our 20+ interviews with fresh food vendors in Kampala, we have not only learned that they would buy a product like FREO, but we have tailored FREO specifically for their needs. And lastly, with more than 20,000 fresh food vendors in the capital city of Kampala alone, we believe this is a big enough market where we can initially start there and then expand to the rest of Uganda. FREO will use a licensing deal to get our product into the hands of vendors. Currently, as mentioned by Matt, Beatrice buys produce from a food distributor. Most of the time, a middleman is hired in this process that physically transports the food to the location where Beatrice is located due to physical and security reasons. Therefore, by limiting the amount of times she has to buy food, we limit the overall cost that's spent as being a fresh produce vendor. We will do this by acquiring a patent through OU. We will use this patent to target local manufacturers to create the FREO using local materials. When designing FREO, we designed it so it could be built in Uganda in mind. In Beatrice's specific case, she would require 2 FREOs for her quantity of tomatoes. These 2 FREOs, if sold at our recommended amount of $25, would have a return to the local manufacturer of $50, and then we as OU or FREO would receive $1.50 using a 3% royalty fee. In a much larger scale, if 100 FREOs are sold to vendors, the local manufacturers would get $2,500, and we as APD or OU would get $75 of that initial investment. In conclusion, we have chosen Kampala, Uganda as the best initial target market, giving many characteristics, and we have chosen licensing to be the best way to get our product into the hands of fresh food vendors. I will now hand it over to Stephanie to talk more about financials and next steps.
Thank you, Mario. Licensing FREO to a manufacturer in Uganda will generate revenue. By year 5, one manufacturer will generate more than $70,000. This estimate comes about one manufacturer selling 2 FREOs per market vendor, each unit priced at $25. This will generate impact. It will create jobs. And each manufacturer will have an increase of 1,400 market vendors as their customers. This is based on previous financials of CCEW projects and a similar social entrepreneurship project from Stanford. Empowering women in entrepreneurship will be an impact as well, given that 70% of market vendors are women. Also, this comes from our interviews from non-profit organizations, such as Development Initiative International, based in Kampala, Uganda. We will have a modest financial return, given that it is a social entrepreneurship project. Now that I've told you about how FREO, licensing FREO will generate revenue, I would like to tell you about our future plans for FREO. By year 1, we will file a provisional patent, test our product on the market, and by year 2, we will use the feedback gained from field tests and refine our designs. We will establish official partnerships with manufacturers in Kampala, and by year 3, we will establish official partnerships with more manufacturers in Uganda. If you remember anything from our presentation, we hope that you remember these 2 main points. 1, that FREO will reduce food waste and increase the shelf life for produce for market vendors like Beatrice. And 2, that FREO will save money for market vendors like Beatrice, which can be invested back into the Ugandan economy. Throughout the semester, our work could have not been possible without our amazing team lead, Stephanie Vo, our wonderful fellow, Patrick Richardson, our mentors, Stephanie Owens and Alyssa Boutel, and the amazing support system that the CCEW staff provides. My team and I couldn't be more proud of the impact that FREO will have in Uganda. We are the Agile Product Design Team FREO. Thank you so much for your time, and we will now open the floor for questions. Yes, sir.
I thought I saw on one of your slides that the vendors earn $25 per week or $25 per month, and FREO costs $25. And to me, it seems like the vendors in those open air marketplaces seem very much to be a hand-to-mouth kind of environment where it's very much, I have a couple of dollars, I'm going to go buy my produce, I'm going to bring it back to the market, I'm going to sell my produce. Do you think they have, as much as it makes sense as a return on their investment in terms of saving on the spoilage, do you think they have the capability to purchase the FREO and give up a week's pay or 2 weeks' pay on average if you're buying 2 FREOs in order to get out in front of this thing? I mean, to me it seems as if there may be a struggle in terms of getting them to pay the initial cost of the FREO.
So the question was, how can FREO be priced at $25 if market vendors make $25 a week? So from our interviews, we gathered that market vendors have a working capital of about $15, and they're very interested on this product because it will save them money, and this would be a very good investment for them. So they have that interest, and they would be willing to make that sacrifice.
Okay.
Yes, sir.
Given the limited potential monetary return to OU, what's the rationale for pursuing a patent as opposed to just still partnering and working to get the technology or the opportunity out there? Why is patent important?
So the question was, why is patenting important given of our small returns?
We do have a small return, but if we want any return, we would require a patent. For example, if we license our idea to a manufacturer in Uganda, there's no incentive for that manufacturer to, another manufacturer could just copy our design and then sell the similar product. So what we were planning on doing was creating a licensing deal where there would be benefits for the manufacturer that licensed with us, whether that be current updates in the future. Whenever we refined our product, we would go to those manufacturers first, or other forms of improvements. So it's not a lot of money that would return to us. However, there is a bit, and we would have that connection with them using that royalty deal to continue to push our ideas.
Back there?
Yeah, so whenever you go to a grocery store and there's produce, it's usually in huge amounts of it. And there's some sort of psychological effect of having abundance there. And a lot of distributors that I've gone to with traveling have lots and lots of fruits at once. So will FREO have the capacity to hold a lot of produce at once, and is there some sort of trade-off to being able to show lots of produce, having it sort of contained in a small container? So So what's the capacity, I guess, and does that have any problems with vendors if it's small?
So the question is about how much FREO can hold and about showing the produce. So from talking to market vendors, we've learned that they would want to show their produce stacked in piles and then have a backup in the FREO, but also we want to have that clear lid to be able to display the food as well.
Maybe I missed it, but FREO will decrease the food waste. But food waste in countries like Uganda and Ethiopia is comparable to food waste in countries like the US and Western Europe. So you have specifically African countries or
Initially, when we did analyze it, there is actually a huge amount of food waste that happens in more Western and more developed nations. However, when we analyzed it, we learned that the issue is more of a cultural or social issue, and that there are available options. There are many available options for reducing food waste currently. But when we analyzed less developed nations, we found that there was no cultural holdback, there was no social holdback. They just didn't have the technological need, and that was where we felt our expertise fit, was filling that expertise, that technical need for them. So that's why we are working in sub-Saharan Africa.
We have time for one more question. Bob.
Yeah, thank you. I'm from Uganda, by the way, and I'm just concerned about how versatile is FREO, because I'm understanding the market conditions in Uganda, from the aspects of mobility to the dramatic weather conditions of Oklahoma, in this case, perhaps segment of Uganda. It gets so rainy sometimes, and the market vendors have to adjust immediately. So how versatile is FREO, and how do you think it's going to adapt to such market conditions and environmental conditions too?
In terms of the versatility, do you want to reiterate the question? In terms of the versatility of the product, there is versatility in just the materials that you can build FREO with. The materials that we built it with were ones that we deemed most appropriate and optimal for the design of FREO. However, there is versatility in the range of materials that you can use to build it. And in terms of using FREO in different conditions, we designed FREO with the goal that the market vendors who don't have to carry their produce home would use it. Most of the market vendors that we talked to lock their produce up at night and leave it either in a shed or in the market, locked up and for security reasons. And that's why portability and movability was not one of our key objectives. Our key objectives were optimizing the cost of the material and also its functionality, how cold we could get it, how many degrees down we could get it in order to preserve this food as long as possible.
Thank you.